We are on a discussion about the sensitive ground fault detection. We discussed around 8 sessions about first method, 6 sessions about second method, 4 sessions about the third method, and in the fourth method we discussed about 2 sessions before. And right now we are on the third session of the fourth method. That in this method we use zero sequence admittance of the system for determining the direction. Zero sequence admittance has a real part and imaginary part, which one we should select according to the system. In previous session we discussed that we use G0 or the conductance part for the system if it is coil grounded or normally grounded system. We use G0, and today we are discussing about usage of G0 in another system which is resistive grounded system, and we use B0 for the system which is isolated system or not grounded. Before that, I forgot to tell you about this I0 active part. It means during the fault we will have I0, this is I0, and this I0 will have active part, this part, that is I0 active, and imaginary part, which is I0 reactive part. This I0 active part is this one. This I0 is not in normal condition, the I0 at during the fault. So this active part of I0 is this part of I0, and I0 minimum is the minimum current which flows into secondary side of the CT in the normal condition. It means the current which is flowing into the secondary part of the CT during the normal condition, the minimum amount of that. If our system is with the core balance current transformer, if we have core balance current transformer, then that amount is between 5 to 10 milliamperes. That amount of that I minimum 0 minimum, this guy, that is in the system with the core balance, it is 5 to 10 milliamperes. And in the system with Holmgren current transformer, this is Holmgren configuration. Here in this type of configuration, if our configuration is Holmgren configuration, then we select the amount of this I0 minimum as a 50 to 100 milliamperes. We put in this formula and we find the G0. I mean that if our system is resistive grounded, on that condition we know that this amount of the capacitive current and resistive current try to neutralize, and the decisive part is the inductive part of the current. So what should we do that the inductive part of the current is decisive on that condition? Means that I0 will be in this area, and accordingly as I0 is in this area, so our V0 will be almost in this area. Here it is that this Y0 will be in this area, and the decisive part of this Y0 will be in these areas. As it will be in these areas, so we tilt our symmetrical axis by -45 degree, and the part of the Y0 which is perpendicular, that is the G0. That G0 we select is decisive for the characteristics of this fault. This G0 amount is determining during the fault whether uh, it's going beyond the threshold or not, and we give some thresholds for G0 here. Now we could understand that systems with the resistive grounded, we tilt our symmetrical axis by -45 degree, and we select G0 for the method of direction determination, and this part is the forward and backward is the reverse direction. And when it goes beyond these limits, when the G0 during the fault goes beyond these two limits in the positive side and negative side, then it will try to trip. If this forward selection is selected, then it will trip in the forward direction. And if the trip or the pickup method is selected as the backward, when it goes beyond the negative value of the G0, then it will try to pick up. Very important question is how much we should give this G0, this guy, and the value here, the threshold, how much we should give the threshold, these two values. We give only one of these values, and then the relay itself will calculate the negative part of that. It means when we give it as a 2 millisiemens, then the -2, when it goes beyond the -2 millihenries, this is the backward direction. The relay understand it's beyond the its negative value. For finding that G0 threshold, that our G0 should be greater than this value, we can calculate this value Ks. We already discussed before how much it should be. We discussed that this Ks is the safety margin factor, and it's 1.5 for the underground cable and 2 for the overhead line. And V rated is the secondary rated voltage during normal healthy case from the VTs. It's normally 110 or 100. And this V0 is the threshold value. I0 active is the active part of the zero sequence current, and I0 minimum is the minimum current which is flowing into the CT during the normal condition. We already stated that if we use core balance current transformer, it's about 5 to 10 milliamperes. If it is a Holm green connection, then it is 50 to 100 milliamperes. But the difference is here, previously in the system with the coil grounded or arc separation coil grounded system, we were using 0.1 into √3 V rated. Right now, instead of 0.1, we use in the system which is resistive grounded, we use 0.2. Here it is. That sorry, it's not 0.2, it is 0.02 into √3 into the V rated of it means the secondary voltage, rated secondary voltage during the normal condition. That is the value of this V0 threshold for the system which is resistive grounded. In next session, we'll discuss about which method we should select, whether we should select the G0 or we should select the B0 for the system which is isolated system. It's not grounded, or network if it is not grounded, which method we should select, and how much we should give the value of the B0, and how should we find this threshold. Important point is that in the resistive grounded, we tilt our symmetrical axis by -45, so the phi correction is -45. In the system with coil grounded system, here we do not give any phi correction, we do not tilt our symmetrical axis, and in the system with isolated, we will discuss in the next session. If you have not subscribed our channel, please subscribe our channel. Help us provide you more free educational tutorials.